Hello viewers, today we will see the exercise 6D. Question 1. Points A, B lie on a circle with the center O. So we need to find the value of y. That's one of the coordinates of the point A. So OA equal to OB, meaning OA square is also equal to OB square. They are the radius actually, if you see. So using the distance formula, we already discussed few formulas in coordinate geometry. So using all that, we are going to solve this exercise. So you can just pin those formulas first. -1 -2 whole square plus O and A coordinates we have to check. Y minus of -3y, so plus 3y whole square equal to OB, that's going to be 5 minus 2 whole square plus 7 minus of -3, so that's going to be 7 plus 3y whole square. So -3 whole square is 9 and y plus 3y is of form a plus b whole square. So we just need to expand the formula. Y square plus 6y squared plus 3y whole square is, that's b square, 9y square equal to 5 minus 2, again 3 square, that's 9, and a plus b whole square form. So 49, 7 squared is 49 plus 7 3s are 21, 21 into 2, 42y plus 3y is b square, so 9y square. So now 9 and 9 goes both the side, LHS and RHS. So we just sum up the LHS, that's going to be 16y square equal to 49 plus 42y plus 9y square. Now we can bring this to quadratic equation form. So 16 minus 9, that's 7y square minus 42y minus 49 equal to 0. So it's completely divisible by 7. So we can simplify it further down to y square minus 6y minus 7 equal to 0. Now product is minus 7 and the sum is minus 6. So we need to get it. Minus 7 is minus 7 into 1, that's minus 7. Minus 7 plus 1, when you sum up, you get minus 6y. So sum is minus 6 and the product is minus 7. So accordingly, we can rewrite it. Y into y minus 7 plus 1 into y minus 7 equal to 0. So y plus 1 into y minus 7 equal to 0. So y equal to 7 or y equal to minus 1. So that's the coordinate, y coordinate of A, which can be 7 or minus 1. Question 2. If a point A is equidistant from the point B and C. So equidistant again meaning AB equal to AC. And we need to find B. So from equidistant we can conclude AB is equal to AC. So AB square equal to AC square. So by using the distance formula, We can write this as, first we can see the A, B coordinates, 0 minus 3 whole square plus 2 minus B whole square equal to, now A and C coordinates, 0 minus B whole square plus 2 minus 5 whole square. So that's going to be 3 square minus 3 square is 9. 2 minus b whole square, it is of form a minus b. So we can expand it, 4 plus b square minus 4b equal to b square. 3 square is 9 plus 9. So p square and 9 goes off in both LHS and RHS. That's going to be 4p minus 4 equal to 0. So p equal to 1. Therefore, value of p equal to 1. So wherever p is there, we can substitute this value. Next question 3, ABCD is a rectangle whose 3 vertices are given. Find the length of one of its diagonal. So let's take BD as a diagonal. So we know BC and D coordinates. BC and D coordinates. So with that we can calculate length of BD. So the diagonal BD, we know that using distance formula, and in the right angle triangle, as per Pythagoras theorem also, square of the other two sides, sum of square of other two sides gives the third longest side. So BD equal to square root of 4 minus 0 whole square plus 0 minus 3 whole square. So that's going to be 4 square is 16, 3 square is 9. 16 plus 9, that's square root of 25. So which is going to be 5 units. So the length of the diagonal BD here is 5 units. Next question 4, if the point P is equidistant from A and B points, so equidistant meaning PA is equal to PB. We can find the value of K with that relationship, PA equal to PB as it's equidistant. So PA square is also equal to PB square. By using the distance formula, we can get the value of K. So with all the formulas we have used in the previous exercises of the coordinate geometry, we are going to solve this entire exercise using distance, section formula, midpoint formula, and the area formula. So you can just pin all these formulas at the beginning of this chapter so that during the exam, you can just glance and go, so you can approach the question easily by knowing what formula to be applied for what sort of question. So we got the PA square equal to PB square using the distance formula. So 3 plus 1, 4 square is 16, and you can expand as per A plus B and A minus B whole square. And then we see 2k square minus 8 minus 4 is minus 12k, and the numerals minus 10 from the RHS, 1 plus 9, so that's minus 10. If you see now, it's completely divisible by 2. So for the simplifying this, k square minus 6k plus 5 equal to 0. So the product is 5, sum is minus 6. So this can be written as k square minus k minus 5k plus 5 equal to 0. So k into k minus 1 minus 5 into k minus 1 equal to 0. K minus 5 into k minus 1 equal to 0. K equal to 5 or k equal to 1. So these are the possible values for k. Next question 5. Find the ratio in which the point P divides the join of a line A and B are the 2 points. So P cuts those points with what ratio we have to find. So using section formula wherein we can find the x coordinate of point P. As y coordinate we already know, we are just applying that formula of y. So that's going to be 2m plus 2n equal to minus 3m plus 5n. So m by n relationship is 3 by 5. So that's the ratio by which the point P divides the line AB. Next, question 6. Prove that the diagonals of the rectangle with the vertices are equal and bisect each other. So ABCD is a rectangle and the vertices are given. We see AC and BD are the diagonals of the rectangle. They bisect each other equally. So by seeing the diagonal length AC and BD, we can say that. And O is the intersection point of both AC and BD lines. So diagonal AC is equal to square root of 5 minus 2 whole square plus minus 1 minus 6 whole square. So that's going to be 5 minus 2 is 3 square, that's 9, plus minus 7 whole square is 49, plus 49. That's going to be square root of 58. Let's see the other diagonal also, BD. If it's same, that means they are equal. So diagonal BD again using the distance formula, square root of 5 minus 2 whole square plus 6 plus 1 whole square. So that's again going to be 3 square 9 and 7 square 49, which is going to be square root of 58. So both the diagonals are same. AC and AD length are same. So they both are equal. Now they bisect at a point O. AC and BD meets at a point O. So by midpoint formula, we can get the coordinates of point O. That's x comma y. Let's assume it as x comma y. So x comma y equal to 2 plus 5 by 2. That's the abscissor x coordinate. Minus 1 plus 6 by 2. That's the ordinate or the coordinate y, which is going to be fractional 7 by 2, comma 5 by 2. So if the point O divides AC, the diagonal, in ms to n ratio, so let's just take the x part of it, 7 by 2 equal to 2m plus 5n, the coordinates a and c, by m plus n. So that's going to become m plus n goes to the LHS, and the 2 from the denominator of LHS goes to the RHS. So 7m plus 7n equal to 4m plus 10n. So m equal to n, which shows the point O is the midpoint of the diagonals AC and BD. Next, question 7. Find the lengths of the medians AD and BE of the triangle ABC, and the vertices are given A, B and C. So two medians are given over here, D and E, which passes through the line BC and AC. So using midpoint formula, we can get the coordinates of D and E. So first we'll get the coordinates of D. That's going to be 5 plus 3 divided by 2, 8 by 2. And y coordinates 3 minus 1. So that's 2 by 2, which is going to be 4 comma 1. So the coordinates of D is 4 comma 1. Similar way, coordinates of E by using A and C, 7 plus 3, that's 10 by 2. Minus 3 minus 1, that's minus 4 by 2. So the coordinates of E is going to be 5 comma minus 2. Now we got the D and E. So using the distance formula, we can get the length. So we are playing around with only the same set of formulas used in the previous exercises of coordinate geometry. So AD equal to, so the length of AD we can find by using the distance formula is equal to square root of 7 minus 4 whole square plus 3 plus 1 whole square. So that's going to be 3 square is 9, 4 square is 16, which is going to be 9 plus 16, 25. And square root of 25 is going to be 5 units. So the length of AD diagonal is 5 units. So similar way, length of BE equal to square root of 5 minus 5 whole square plus 3 plus 2 whole square. That's going to be 5 square because 5 minus 5 is 0. Second part is 3 plus 2, 5 square is 25. So square root of 25 is again 5 units. So AD and BE length are same, 5 units. So both are equal as AD equal to BE. Next, question 8. If the point C divides the join A and B in the ratio of 2:3. So here the ratio is given, find k. Whenever the ratio is coming, we need to use section formula. M is 2, N is 3, or whichever you take it as M1 and M2 as 2 and 3. So k equal to 2 by 3 into 5 plus 1 into 2 divided by 2 by 3 plus. Numerator is going to be 10 by 3 plus 2 divided by, we need to take the LCM, so that's going to be 5 by 3. So denominator is 5 by 3. Now we have to take the LCM in the numerator also. So 3 2s are 6, 10 plus 6, 16 by 3 and 5 by 3. So 3 and 3 goes off. 6 by 5 is the value of k. Next, question 9. Find the point on x-axis which is equidistant from A and B. It's been mentioned the point lies on x-axis, which means y coordinate is 0. So the point P with x comma 0 are the coordinates. It is equidistant. It is mentioned again in the question. So we can just find using section formula x equal to 5 minus 1 by 2. So x value is 2. So the required coordinate is 2. Point is 2 comma 0. Question 10. Find the distance between the points. So 2 points are given. It's a direct question. So using distance formula, we can find square root of 2 by 5 minus of minus, that's plus 8 by 5 whole square plus 2 minus 2 whole square. So it's a like fraction. We need to just add the numerators. As 5, the denominator is same for both. So 2 plus 8 is 10 by 5 whole square, which is going to be 2 square. So it's a square root of 4, which is going to be 2 units. So the distance is 2 units between those 2 points. I believe this is useful. Thank you.